Good day. I'm going to shamelessly rip off some content from Cody. And he posted a video about a React challenge from a junior interview challenge. And I haven't done anything like that in a long time and kind of felt like doing something like this. I kind of skimmed over his video. I have some sort of idea where he went. I'm probably going to do it quite differently. And he was addressing it more as a, if you've been interviewed, how would you go through it, and possibly how to interact with the interviewer, I believe. I'm not going to really focus on it, but let's go through the description. We have an input map of country to capital. We're going to display all capitals and buttons in random order, all capitals and countries as buttons in random order. Clicking a button sets its background to blue. Clicking another button does remove a pair if it was a country capital pair. Else it's going to mark both buttons red. And if a previously selected pair was wrong, clicking another button should restore the button color of the wrong pair and set the background color of the click button to blue as in point 4. And when there are no buttons left, display the message congratulations and export it as default. Now, first thing, when we read this very carefully, and we should always read the task carefully. We shouldn't jump directly into programming like Cody did. But we're going to notice that this question is actually badly formulated. And that is something you should talk with the interviewer about, because this could be a trap. And if I was interviewing someone, I might put this as a trap in there. And let's go through this and actually figure out what was written. We probably know what was meant. And quite often in the real work environment, you'll encounter a lot of stories and tasks where the description is possibly wrong and you need to interpret into it. Or go to and ask the author, hey, how did you actually mean this? Because what you wrote here is probably not what you wanted. And that is a very valuable skill to have. Now, first thing we see, we have one click, then another click, and then if a previous selected pair was wrong, click another button. But there's no repetition here, as in point 4, not a repeat from point 4. And when there are no buttons left, display message congratulations. So we could, in theory, only process the first 3 button clicks and possibly only process the 3rd button click if there was a wrong pair. Because that would fulfill the task. Obviously, that is not what they meant. Probably. But talking about this and might help you also to demonstrate the skill that you're actually capable of reading carefully, which is a lot of people can't do that. And that is a very valuable skill. Always analyze the question first. Think about what does it actually say, not what do you think it wants to say. Because those things can sometimes be subtly different, and sometimes that is what is actually written is what they actually want, and that can be disastrous if you then interpret something else into it. I've seen that a lot of times. Both ways, that it was implemented as written, which was wrong, or that it was implemented as interpreted, which was also wrong. Yeah, anyway. Sorry, I'm sick as usual. We're going to start from the very beginning. React button game challenge. It wasn't React, so I'm gonna do React. NPME. We're going from the very start through this. There isn't much here. I'm probably going to ignore the export as default because that's not interesting, and I think anyone can figure it out. I'm also going to approach this much more from the functional perspective. So let's go into our application. Let's start up the dev server. And if I click on this, and then if I click on this, copy, and then, oh, there we go. I just took a good year. Okay. Never mind then. I'm going to make this a bit smaller because my screens are overloaded. Let's go to the secondary screen. And we can just delete all of this. We don't need any of this. And let's set up the thing we need. We know we have a button game component of some sort, which for now is just going to return some value that we know that we're actually successfully rendering. And then we can return that here. And if we look at our screen here, we see we get our a rendering here. Nothing exciting. Basic React. So, first thing first, we know the game input, right? So, game button, game answers. Is a mapping from country name to country capital, right? So we also know this is the input here. This way, I believe. And let's put this also in here. It's been a while since I've written React. And I'm not going to put countries in here because this is much faster and also allows us to see all we want to know about this, right? So reloading it, we didn't get any errors. So next thing, as I said, I promised I'm going to do this functional. So we're going to define our state somehow. We have a thing called game button game state, which has some values in here. We're also going to have a function to update our game state. Well, let's call it next game state, which takes in our state, which is a button game state, and something else, and it's going to return a button game state. What I'm doing here right now is absolutely standard for functional programming, and it's also standard for, you might recognize it if you know the use reducer or Redux in React, because that is just directly stolen from functional concepts. So if you know how to use that, you're actually, you shouldn't be surprised by most of the things we're going to do here. Obviously, this is a compilation error, so we should write something else in here. We can just do some sort of action. Something happened. We can just say this is any for now. We're going to think about what this thing actually is later. We know that we have a game over state, which is a boolean. We also want a function to initialize our game state, which will take in I have caps lock on. That explains a lot. I was wondering why I can't hit buttons. This is going to return a game state. And it's going to accept our answers, because that's our input. And we can return this thing here. And our game over is false. Actually, it's not always false. Because if we start with no inputs, if the answers here is empty, then we are already going to fulfill the condition for the game over. Right? So let's think more about the state. I do type-driven development. I think a lot about the state, our states and types, but I also evolve them over time. I don't want to overdo it. But we know we're going to have our answers in here, right? Button game. Answers, because we need to check somehow if we're correct or not. We also know we have some sort of options, the things we're going to display, the things that are clickable, which is just going to be a string array. So let's put these in here. Answers can just be answers, and options we can compute up here. Const options equals object.values of answers, and then object.keys of answers. And that goes into an array. Like so. And then we can return, put our options in here. Now, this isn't going to be correct because it's, if we recall, it was supposed to be in random order. And this isn't random, obviously. So since JavaScript's a actually quite bad language, it doesn't have anything for this, but we can define our own shuffle. When I skimmed over Cody's stuff, I saw he was using .sort math random. That will work, but it's kind of a bad idea. I'm not entirely certain if it's going to be a uniform shuffle, first of all, as an unbiased, and secondly, technically, that is undefined behavior. At least in most languages. I'm not entirely certain if it's defined behavior in JavaScript. But in most languages, a comparator that returns random values is undefined behavior, and the sorting algorithm could do any number of things, including throwing exceptions. And we're working in a language that can throw exceptions, so that is something to watch out for. Now, in JavaScript, as janky as it is, it's going to work. But let's do a proper shuffle. If I remember this correctly. So we're going to take in some sort of array of some type t, and we're going to return some sort of array of type t. Let's create a copy of it immediately. And let's return res here. And then for let I equals res dot length -1, I will explain how this algorithm works in a second. Let j equals map dot floor, and then map dot random. And then we're going to multiply this by b plus 1, yeah. And then we're going to swap them. Yes, that is correct. Okay. So, what's going on here? We're going to iterate from the back of the array with some index. Then we're going to pick a random index from the before. So we're always swapping the last item with a random one to the left of it. Any one of them. And we're going to do that for every element. And that's going to be an unbiased shuffle. If I recall it right. I should be recalling it right. Assuming the math.random here has actually good randomness and entropy, which doesn't. JavaScript random is actually quite bad. But let's move on from the ranting. We don't have compilation errors, which is good. Meaning we didn't mess up horribly. But we can now shuffle our options instead. Okay, this is kind of far enough to maybe test something. Just to convince ourselves that that shuffling works, for example. Obviously, we should just write tests to cover shuffle error here, but we could do an init game state now over options here and just log that out into the console. And unwares is not defined. Yeah, unwares is not a word. Unwares? Where did I write unwares? Answers. And answers. Unwares. Okay. Right, I did that a lot. Okay. What's that? Yeah. And then unwares replace with answers. Okay. Now if we go over here, and we should see that our options here are shuffled. B, A, B, A, which doesn't seem shuffled. But if we reload, then our options array is still not shuffled. No, it is shuffled, because we are starting with values first, and then I might need to reload this a few times or add some more options. Maybe we'll add CC into this. Yeah, now we have a different order. B, A, A, B. Okay, so it shuffles, but with just obviously for permutation reloading a few times, you run a high risk that we're going to end up on the same permutation. Okay. So let's remove this useless thing here again and think about what to do. How does this game actually work? So we have some sort of selection. We can select a button. And this should be a number. And I thought about a potential pitfall, which I'm not sure if Cody took care of. I'm going to look at his solution carefully later and see if that bug is in there. I'm going to explain it in a second. And then we can also mark our errors, right? Because if we remember, a pair could be in the error state. Now, let me just add this in here. We have selection starts off with nothing selected, and errors start off with no errors. And this here is actually options length. Equals 0. If the length 0, then we are already game over. Now, what is the problem if this is a string? And I was just thinking about it. There are countries, this is string, right? There are countries that whose capital have the same name as the country. Meaning, if we had a selection which is a string here and an error which is a string, it's saying, okay, we selected Luxembourg here. That could be the capital or the country, because that's one of those countries. And then we would mark 2 buttons as currently selected, or up to 4 buttons as errors if we have 2 of those things. No, we want to instead actually mark which buttons specifically were clicked. So we're going to use indexes instead, which is the better choice anyway. Okay, this already kind of gave us a hint what our action is, and that is we're selecting something, right? So we know this is selected, which is going to be a number. And now we can start actually working on our logic. So first thing we know is that if the so first thing we can guard ourselves simply if selections smaller 0 or selection larger equals a state options.length return state, just don't do anything. On the same thing we're going to do if state dot game over, just don't do anything. What other options do we have? If the selection equals to the state dot selected, then we're also going to return state. These 3 cases make sense, right? Because if we are game over, we don't want to continue playing, the state should stay the same. And if you clicked the same button twice, we shouldn't change the state either, because you didn't change any selection. Now, there is the matter of we clicked the same. So now we clicked the first button, right? We have a selection state dot selected is undefined. In this case, we can just return the state with the selected to be selected. Selection, did I call it selection? Selection. Okay, I need to be careful here. Selection, and then this is selection, and this is selected. This is selected. This is selected. Okay, I need to be very careful with those names. Sorry, I'm working without a language server right now. I'm getting only syntax highlighting. Healthy exercise every now and then. So, we also know from the thing where we said if you click after the error state, if you click something else, the error state should revert, right? So we know we're going to reset the error here. Now we have two more options. We're in the case where we selected the second one, right? Because we already something selected and we're dealing with the second press. So there are two options. That selection is valid, as in we hit a game state, or we hit an error. So the way we can check for this is we can get one of the values, which is state.options of selected. The other one is state.options of state.selection. And then let is pair. We can do state answers x equals y, or state answers y equals x. It's one of these. And then we can do if is pair. Then we're going to return our new state here. And what did change in the states? First, our game over could have changed, right? And that is if the previous array was length 2, then we're going to be length 0 now. So we ended the game, because we're going to remove 2 buttons, right? So we can do state.options.length, let's say smaller equals 2. Because if for some reason we already, this can't happen, but yeah, whatever. We need to remove from our options the 2 indices. We actually don't care about the value, we just care about the index. And if the index is not selected, and the index is not the previously selection, that's it. Yeah, we keep them if the index is neither of these, right? And then finally we need to reset our errors. And I did that mistake. Been writing a different language a lot recently. Do we need to reset anything else? Our answers stay the same. And we need to reset our selection. Becomes undefined. Because we just selected a pair, so there's no first selection anymore. So, in the other case, we're in the error state here. So we can return our previous state here. We know the error state is now the selected and the previous selection. And the current selected is also undefined now. That is the two changes that happen here, right? Options don't change, answers don't change, game over state doesn't change. Yes. Okay. We run into a compilation error. State.selection equals undefined. Wrong language again. Where did I write it? Down here. More compilation error. What is it? Internal unexpected token, comma. Because this is not state dot, but just state. Okay, now we got no compilation errors. And this is the function. This is the entire game logic. This can be perfectly tested with unit tests. And all we need to do is just actually display this in here somehow. So we need to keep us in a state. And in a game state of options. I'm using the lazy init because we don't run through this every time. Doesn't matter. You can do it directly as well because it has no side effects. But one thing is we cannot detect if the options change right here. A lot of people grab a use effect here. I don't like use effects. And this is not really the best case for a use effect, to be honest. Because what we're going to do is the use effect is going to do for us anyway. And we're going to do that inside the use effect anyway. So we're not actually gaining any performance from using a use effect. And the use effect is goal is to do side effects. And we don't want that. So if options, we can't do this because JavaScript's a bad language. So let's write a function for this. Function is same game input. It takes in A, which is a button game answer, so B, which is a Jesus Christ button answers, and it returns a boolean. And then for let key in a if a key equals unequals b key, return false. Return true. And we're going to flip this here, right? So we're checking every key in A. And we're going to check every and test if it's the value for that key is present in the other object, and then we're going to flip it because it's possible that the number of keys in A is smaller than the numbers of keys in B and the other way around. And again, writing a different language where you don't put brackets and ifs and fors and other things. Anyway, doesn't matter. And if we didn't find a mismatch, then we know that all key value pairs are the same and we can return true. Like I said, in other languages, you can just directly write equals because you should be able to do, but whatever. And And then we can do is same game input A, B. And in this case, we can set the state to init game state of options and return null. Because we don't want to render our false input. We would be lying at this point if we rendered our previous state, because our inputs don't match anymore. We don't want to complete the game logic. Now, this could cause a flicker. So we could also say a let state here instead and do a state equals of options here. And then we can put the state in here, skip this part, and then we can just render the new state. It doesn't matter. Now, why do I say this does the same thing as a use effect? We imagine a use effect. The way we'd write it, if I ever hit my keys, something like this, right? And then we have our dependency array here, and we would put our options in here. Now, this doesn't equals here, so we still need to write this entire if statement inside of here. And we don't really gain anything. Because it does this comparison for us here. Obviously, we could, if we didn't want to do the comparison here, strap this in front of this as well as a fast escape. Just say options equals state or, right? So if there is unequal state, so this shortcuts. If they're not the same, no. Wait. If they're the same, yeah, if they're not the same, and this way around. Because if they're the same, we don't need to check their content. And this has a much better performance than the use effect. And it isn't an additional hook we have to care about, and we can place it anywhere we want. Right. And now we just need to do the displaying thing part. So we're going to show buttons. So this is just going to be state.options map. And this is the option. And we do care about the index because our actions are on the index. And we're going to just render button of our input. And our onClick is going to be quite simple. We're just going to call setState on next game state of current state and the index. If we do that, we get a compilation error because this is not how you write Java, not React. Let's put this into the next line. Like so. Now I got the syntax right. And let's see if this worked, right? So, okay, we don't see anything here. A is not defined in line 71. Why did I write A and B? This should obviously be options, and this should be state dot answers. And that should be state dot answers as well. Let's got no compilation errors. Look at this, clear this, the errors, reload this, and we see nothing, which is interesting. I think this is unrelated, right? Yeah, this is something unrelated. Let's do a console log of our state and see if there's something wrong with that. Looking at it, we see we have options, which is filled. We have errors, which is empty. We have our answers. Game over is false. Selection is undefined. There doesn't seem to be anything wrong with that. We don't have any early returns. Ah, there it is. Syntax again. I've been writing a lot of Rust where there's an implicit return and yeah. Now we have it. We've got A, B, B, and if we reload this, we should get different orders. B, A, B. Yeah, this is a different order. And React already screams at us because we have different key orders, which we can easily fix here by saying key equals the index, actually. That's fine. It might still scream at us. No, it won't, actually. Alice Lind would scream at us. Okay. So, let's see if the game works. So if we click A, B, okay, wait, I'm going to put the console log statement back in. Console log state, because we need that. Right, so if we click B, then the selection is free. That is okay. And if we click A, then we get 2 errors. This is not correct. We should get errors here. What did we mess up? Set state, next state, state of our current state, and the button we clicked on. That is okay. So this puts the suspect on here somewhere. Ah, this is the case. Yeah. No, this isn't the case. This one works. If selector is undefined, let's put in some debug statements. Console log x, y. And if we look at the game, then we never get this console log. Meaning we are getting thrown out before. Is our game over state? No. Console log 1. Console log 2. I just want to know if we ever reach any of them. So we reached both 2 and 1, and I should have numbered them the other way around. And then if we hit capital A, we hit 2 and 1 again. But state select... Oh, okay. Found it. I said I had to be careful with that. That is selection. And I don't like that. I don't like that in JavaScript. That's not an error. It's just whatever. Okay, so if we click B and then click A, then we should get our error array 1 and 3 were the wrong ones. There's no selection. If we click B, then the selection is currently 3, and if we click capital B, then they disappeared, and if we click AA, then they disappear. Okay, that seems to be correct. Let's get rid of our random console logs. And now it's just the game over message. If state.game over, return congratulations. And we need the highlighting, which I'm going to do super lazy. There's better ways of doing this. But I don't care. So if I equals state dot selection, right? Selection, yes. Getting paranoid. Then we're going to go selected class. Else if I state dot error dot includes I, then we're going to go into the error, and else we're just not going to be in a class at all. And this should be fine. Class name in React, was it, I believe? Yeah. And then let's go to index and define button.selected with a background color of blue and button.error with a background color of red. And if we go to our thingy here, we see we get a bright red when we mark an incorrect pair. If we click just one, we get a blue one. And if we clear the map, we get a congratulations. And that is it. So we can see that there's basically no logic at all in my button game here. The only thing it does is hand over to the game logic here. That's all it does. And that's also kind of how I like to model my React stuff. If I have to work with React, is just don't deal with React, basically. We could have used a use reducer here instead, and then used the dispatcher here. That would technically do the same thing. But it's just another extra hook you need to use. And you have a function here anyway, so you might as well just call the function anyway. It's more useful if you pass it downstream and you get events upstream again, because then you don't have access to the state here. But we have access to the state here, so it's completely overkill. Anyway, that's it. Hope you enjoyed, and see you around.